Hi everyone. In this lecture we're going to talk about word problems. Now word problems in algebra is something everybody fears. Because what we have to do is we have to take a text like this and turn it into an algebraic problem. And how to do that, well, that can be very confusing sometimes. And the reason why it's confusing is because there's a lot of different kind of word problems. Here I have on the board a mixture problem, which is one of the many different types of problems. And because there's so many different types, and each type has to be handled a little bit differently from the others, people get really confused. So what we're going to do here is we're going to walk through a lot of these different types of word problems, and we're going to start with mixture problems, and as the lecture goes on, we'll go ahead and do a lot of different types of problems so you can see how they're all handled. All right, let's read this one. One of the things you need to do when you do mixture problems or any kind of word problems, you need to read the problem very carefully. So here goes. It says, how many gallons of a 30% acid solution must be added to how many gallons of a 70% acid solution to make 50 gallons of a 40% acid solution? So you read that and you go, wow, I don't even know where to start. Well, there's a very handy little technique that I like to use. And that technique is to turn something that is like a text that's very confusing into a graphical representation that makes it really easy to figure out what's going on. So what I recognize is that I'm mixing two things together, two different kinds of solutions. One that's a 30% solution to one that's a 70% solution, and that will produce a mixture that is a 40% solution. So what I'm going to do then is I'm going to write that this is a 30% solution, this is a 70% solution, and this becomes a 40% solution. All of a sudden, this problem is not so complicated anymore. I can now clearly see that I'm mixing two different kinds of solutions to produce a third solution with a particular concentration of acid. Also in these boxes, we want to put in there how much of each that we have. Now, it doesn't tell you how much you use of this solution, and it doesn't tell you how much you use of this solution. Matter of fact, that's what you're supposed to figure out. But it does tell you that you have 50 gallons of this solution. All right, so we put 50 gallons over here. So, how many gallons do we have here? And how many gallons do we have here? Now, if there's two different kind of solutions you're adding, and you don't know how much of each you use, you typically let x be the amount you have of the one solution, and the total minus x be the amount you have of the other solution. So this, you write in x gallons of that solution, and the total, 50 minus x, be the amount of the other solution. And now you're ready to start solving the problem. The product of the amount of gallons that you have with the percentage of acid that you have in the solution, that gives you the total amount of acid. So if I multiply these together, I get the amount of acid I have in this solution. If I multiply these two together, I have the amount of acid I have in this solution. And if I multiply these two together, I have the amount of acid I have in this solution. And the amount of acid in this solution plus the amount of acid in this solution equals the amount of acid in this solution. So simply put, in algebra, or in algebraic terms, we write 30% times x plus 70% times 50 minus x equals 40% times 50. And all we have to do now is solve this algebraically, like solving a linear equation, to figure out how much of each solution we need. All right, so now we just use our techniques that we've learned before of how to solve linear equations. First of all, we change the percentage into a decimal. So 30% is the same as 0.3 times x plus 70% is the same as 0.7 times 50 minus x, and 40% is the same as 0.4 times 50. Okay, now we have an equation that has decimals in it, and we don't like decimals, so we're going to multiply both sides of the equation by a number to eliminate those decimals, and it looks like all I need to do is multiply both sides by 10, because then the 0.3, the 0.7, and 0.4 turn into a 3, a 7, and a 4. So I'll multiply the left side and the right side by 10. Of course, remember, if you're going to multiply something on the left side, you must multiply the right side by the exact same thing. Okay, let's do that now. So 10 times 0.3 is 3, so I have 3x plus 10 times 7 is 10 times 0.7 is 7. Multiply that times 50 minus x, and 10 times 0.4 is 4 times 50. Okay, now we just simply go ahead and get rid of the parentheses. So I have 3x plus 7 times 50 is 350. 7 times minus x is minus 7x equals 4 times 50 is 200. And of course, what we do here is we move all the terms with the x to the left side, all the terms that don't have an x to the right side. So I have these already in the right location. 3x minus 7x equals 200. And when we move the 350 over the other side, remember we changed the sign. This becomes minus 350. 3 minus 7x is minus 4x. 200 minus 350 is minus 150. Divide both sides by minus 4. The minus 4 cancels. And 150 divided by negative 4. That gives me x is equal to, that goes in there 37.5 times. Quick check to make sure I did this correctly. 4 times 30 is 120. 4 times 7 is 28. 120 and 28, that's 148. 4 times 0.5 is 2. 148 plus 2 is 150. All right, I have the answer here. So that tells me that I need 37.5 gallons of this solution and 50 minus 37.5, which is 12.5 of this solution. So the answer is we need 37.5 gallons of the 30% solution, and we need 50 minus that, which is 12.5 gallons of 70% solution. So quick recap, you read the problem carefully, you recognize you're adding two mixtures together. One mixture is 30%, the other mixture is 70%, and you want finally to end up with a mixture that's only 40%. They tell you that you end up with a 50-gallon mixture. They don't tell you how much of each of these two mixtures you have to add, so you let x be the amount for the one, and the total, 50, minus x be the amount for the other. When you multiply them together, you get the amount of acid in each mixture. That should add up to the total amount of acid when you put the two mixtures together, and then algebraically solve for x, and you put down your answer. And that's how you solve a mixture problem.